Right, welcome to the fourth lecture on mathematics for machine learning. कल हमने क्या डिस्कस किया? Right. So broadly we discussed three things, right? Why are machine learning methods so powerful? What are their limitations? And how do they relate to some of the mathematics that we have already seen, or at least the concept of learning in the math that you have already seen, right? So we said that firstly, the universal approximation theorem tells us that neural networks have the capacity, right, to learn different functions. Yeah, that's the key thing to start with. If you're going to teach someone something, you always have to check if they have that capacity. Yeah, you cannot try a middle, let's say, a child of class 10. You cannot try to teach them very advanced mathematics. Yeah. So that's all the universal approximation theorem does. It doesn't give you anything else, right? It just gives you some comfort that the structure is rich enough to do this. But so it says if there is a function between input and output fx, right, then the neural network structure can give you a function gx which can be as close to fx as you like. Yeah, if you keep increasing the neurons. So we found that this thing also lies in polynomials and Taylor series and Fourier series. They can also do that. Yeah, but the problem there was they are not heavily parameterized and they are not designed to generalize things. They are good at fitting curves. Yeah, so in general, the problem that we deal with in machine learning and a lot of other approximation is not about giving the exact values that I know or the function. For example, we might say, okay, there's a function fx that I want to approximate by gx. But in real situations, we normally don't have that function which we want to approximate. We don't have fx. What do we have in general? Data. So data are kind of glimpses of fx. They are not fx, right? So in general, when we don't have fx, we need something else that we could do. For example, let's see if this can work. Yeah. So we don't have access to fx, which we are trying to approximate. Instead, we have access to some instances of fx. That's the data in simple one variable case, right? Two variable case, it gets a bit harder to draw, but the idea remains the same. So an approximator would try to fit something in here, yes? And different approximators would do it differently. All the universal approximation is saying that the neural network model, the linear weights with activation, can fit various functions in here. Yeah, so does polynomial fitting, so does Taylor, so does Fourier. Yeah, but the interesting challenge comes in when we are asked to say, okay, what are the values here? Yeah. So we know the values, some of the values at data points that we are trying to fit, but then, for example, what are the values here, or what are the values here? Extrapolation, interpolation, extrapolation. Then we might also be interested in asking that I have two sets of these data, or three of these, for example, 1, 2, 3. Which two of these come from the same class of functions? Yeah, or some functions that are very close to each other. And that is where things become rather complicated. Okay, and that is where the over-parameterization of neural networks comes in handy. And I gave you several hypotheses on why the current community believes that over-parameterization in neural network helps. Yeah, and then I said over-parameterization alone would lead to too much computational complexity. Yeah, so then there is this additional structure inside neural networks that allows repetition of simple rules to be applied. Yeah. So I had thought of a more detailed example, but maybe it's a bit early. When we do go back to neural networks, I will show you with some data interpolation example where traditional approximators may just fit that function very well, but may not be able to predict very well. Okay, so that is the summary of the first main part that we did. Today's lecture is mainly about this thing, vocabulary. Vocabulary क्या होती है? You know, right? Dictionary में जो लिखी होती है. Yeah, vocabulary is the language, the terminology. Yeah, so often एक field के लोग दूसरे field को क्यों नहीं समझ पाते? Accountant बात कर रहा है surgeon से, दोनों को एक दूसरे की समझ नहीं आ रही. Yeah, why? Because the language varies a lot. Yeah, so to get into a field, to have a discussion, to actually have some thoughts about it, to do research in a field, the key thing to start with is the vocabulary. आपकी vocabulary clear होनी चाहिए. आप अगर you hear a term, you hear one term you don't understand, you might manage. You hear two terms, still manage. If you hear 10 terms in 2 sentences that you don't understand, then it's like, I don't know which language you don't know. It's like French, Greek. Yeah, all of a sudden you stop paying attention. Your brain stops paying attention because, okay, I have no idea what this is. Yeah, so usually in my courses I spend a week in almost every course talking about the key terms that we will be using in that course. Yeah, and at this stage usually my idea is to give you an overall understanding of it, not really going deep in that. We will do later. Yeah, but this will also help you because this is a graduate course. We are a bit fast paced. I already suggested that you start looking up topics that you will be writing your term paper on. So the vocabulary you learn here will also help you start making sense of what you read, let's say in research papers or in more modern books on machine learning. Yeah, so without that you might get overwhelmed. You say, oh, what is this back propagation? What is this activation function? Within a sentence there will be 3 terms you won't get. Okay, so let's start with the vocabulary. It's important. ये पता है अमीर खुसरो का शेर किसी को आता है पूरा? मिसरा तो आता होगा. ज़ुबान यार मन तुर्की व मन तुर्की नमी दानम. My beloved's language is Persian and Turkish, and I don't speak Turkish. So मुश्किल हो गई. Yeah. So the idea here would be to change that, and let's see if this works today. Good. So this is the general idea. We'll talk about some general terms, broad classes, ML map, associated vocabulary, neural network map, and associated vocabulary. Most likely we will do maybe first 2 or first 3 today. Yeah, depending on what I see on your faces. Okay. परेशान बैठे होंगे तो फिर हम slow देंगे. Right. So let's start here. Still an issue. Learning versus regular computation. I've already mentioned this, right? First lecture में ये था, I think. So regular computation, or this regular computation is also called the von Neumann computing paradigm. He was a big guy, just like Alan Turing in computer sciences, the people who thought up the idea of the modern computer. Okay. Interestingly, at the time of von Neumann, this machine learning idea was already there. It had started, and he looked into it, and he thought it was a good idea. But because of hardware constraints, because of data constraints, the traditional computing method, which is what? That traditional method took over the world. So all of our computing, or most of it, has been based on this. जो हमारी digital revolution है, so far, 5-6 साल पीछे तक at least, has been built on this thing, which is there is a machine, a computer, yes, a logical processor. You give it rules. Rules means a code. Yeah, for the machine, it's a program. You give it program, you give it data, and it gives you answer. This is regular computation, or von Neumann computational paradigm. Yeah, the learning paradigm turns this thing over its head. It says, I'll give you data and the answers, and you will tell me the rules that created these answers, so that I can then give you new data and we can use the rules. By the way, once we have learned the rules, we go back to the traditional paradigm. So they work together. It's not like the original paradigm of computing is gone. It's still here. Yeah. Once the rules are learned, we put them here. Yes. Aapka learn model, and now it's just operating. And in a more advanced sense, this thing goes in cycles now. ChatGPT is not only giving you answers, it's also learning from your questions. Okay, so transitory transfer learning is a concept now. But basically, that's the first terms that you need to understand: learning computation versus traditional computation. Yeah, right. So then we need to define learning. We need to have some sort of an operational definition of learning. Yeah, and it's usually attributed to this guy, Tom Mitchell, Carnegie Mellon. And this is, I call it an operational definition, meaning it works well for us. Okay, so what is learning? A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance in T as measured by P improves with E. ठीक है, समझ आ रही है कि नहीं? है कुछ आई समझ? 3 लेटर्स हैं इसमें. क्या क्या लेटर्स हैं? T, P और E. T है टास्क. कोई काम हो ना, आपको दिया हुआ है कि ये कोर्स सीखना है, या स्विमिंग सीखनी है, साइकिलिंग सीखनी है, कोई काम दिया हुआ है, टास्क है. ठीक है. फिर ये क्या आपको मौका दिया गया है एक्सपीरियंस समहाउ लर्न करने का. Right? More data is coming in, more instruction is coming in, more feedback is coming in. Cycle को ऐसे करना है, ऐसे नहीं करना. Yeah? You are given opportunity to gain experience E through data, through feedback. वो भी data ही है. Yeah? But then P का क्या काम है फिर? Your performance is judged against something also. Right? जो कैसे पता चलेगा कि आप बेहतर हो रहे हैं या नहीं? So there has to be some judgment criteria that will be the measure of your performance, P. So basically, learning means a program that has a task to do, and there is a measure which will check how well it is doing, and there is input data given to it as experience for training. And as the new data or the amount of data increases, the program gets better at its task. How does it get better? The performance measure P goes up. अच्छे से अच्छा वो value ला, या accuracy, let's say P may be accuracy, P may be the mean square error. In that case, we want P to go down. Performance should go up with experience, with the addition of data. Now, this is more of a operational definition, and this is again, just to summarize it, there is a process, there is a task that is to be done, experience is coming in and it is being measured and then it is improving. Yeah. Input experience could mean what? Input data, you give housing prices to a machine learning algorithm, you give customer transaction, you give images. Task means what? Predict some prices, predict a value, predict the performance of a student, categorize images, is this image of a car or a bicycle. Performance measure, there could be many different, accuracy, mean square error, variance, we will see those. Yeah, but essentially it's this PET, maybe you can call it. Yeah, so these are the three things involved here. Now this again gives you the same idea, just in a slightly different diagram. Now let's put it in a bit of mathematics now. Yeah, learning minimal mathematical formulation. I'll tell you why I call it minimal at this stage. This you will recognize better. Assuming or hoping, because we can't prove many of our assumptions, so we say, okay, let's hope there is a relation and we want to find it. There exists an unknown functional relationship between two classes of entities. Yeah, when we go into the linear algebra part, we will define what we mean by the classes and entities, spaces and their subspaces and all that. Yeah, but for now let's just call it this. Functions पढ़ते हैं आप, mapping पढ़ते हैं, right? So basically there is a class X, group or set X, there is another one Y, and we assume or hope that there is some mapping between them. Yeah, let's say it exists. This is our assumption, at least there is a mapping between them, and assuming that there is a class of candidate functions H. The board I'm not using, so maybe I should close it. Okay, move to that. Okay, you can still read, I think. Now, further assuming that there is a class of candidate functions H, hypotheses, the goal is to choose or learn the candidate function H from H, which will satisfactorily replicate this mapping. So what does this mean mathematically? This is what it means. Let's close this thing. Yeah, there is a bag, आपके पास कोई structure है, there is a bag of hypotheses, basically functions, yeah, candidate functions, and from that bag you are going to pick one that is the best. What is going to define the bag? Possible functions किससे define होंगे? जो model आपने choose किया है, कितने न्यूरॉन है उसके अंदर, कितने दूसरे weights हैं, क्या layers कितनी हैं, yeah, or if you have chosen the model to be a Taylor series, okay, what are the different parameters in there? So that's the bag of H. Candidates that can represent F or approximate F. Yeah, so there is this class of candidate functions that is going to represent X. Okay, so maybe I should use this thing. Yeah, this is better. Now, if we do have some samples of known mappings, that is the data that is available. I know that when I gave x, I got y for at least n points. जो हम points होते हैं, जो known होते हैं points, right? Then this may or may not be available. In addition, we will need some sort of a measure P to quantify what we mean by satisfactorily. Yeah. So with that, if we do bring in P, this is what learning is mathematically for us. Okay. What it is there are two entities, classes x and y. We may or may not have some sample data from there, but our goal is to approximate f, find a function that approximate f from within a class of functions that are available to us, right? So this is the task of learning in our case. And of course, how we do it will be an additional thing, but two things to keep in mind. The mapping may be probabilistic in nature. Okay, so the function may be coming from probability theory, not just your normal deterministic function. It might be a probabilistic function. In fact, in most cases, it is a probabilistic function. Data में variations होती हैं. Yeah, so we want to allow that. Also, as I said, we will need to define some sort of measure of error. Okay, how far is a function from the required function f? Yeah, so how do we choose from here? That is of course part of learning. But how do we judge? Let's say there are 10 candidates here, H1, H2, H3. Whichever gives us the lowest measure, we will call it our best candidate. So we have to define that measure also. We are not defining most of these things right now. We are just defining the structure. एक हमने पहले operational define किया PET की form में. Yeah. Now we are defining it in the form of function mapping. Yeah. So once we have this thing, this is our definition of learning. So learning फिर क्या है in mathematically क्या है हमारे केस में? अगर हम summarize करें, when you hear हम आप कहते हैं ना machine learning है, somebody says over what do you mean by learning? So mathematically एक तो operational होगी definition. Mathematically क्या है? It's the task of finding a function that would represent a mapping that we have seen, right? Some examples of, for example. Yeah. So, and the function you pick up or the function you choose to be your best is from within a bag or from within a set of candidate functions, right? Which we call the hypothesis. So, when you hear the word data now, data क्या है? Data क्या होता है? That carries some information. Yeah. From machine learning perspective, we will call something data that our machine learning algorithms work with, right? So remember जो mapping हमने करनी थी या है exist करती. So the input space, the values in the input space are input data. The values in the output space are output data. Okay. So this is basically what the ML is trying to find the mapping between. So for us, data is what? The things, the two entities between which ML is trying to find the mapping. Yeah. And data can be in different forms. Okay. It can be numerical, it can be categorical. Within numerical, it can be continuous, discrete, ordinal, nominal. So I'll let you read that on your own, just to give you a comprehensive idea. Now, Hani. right? देखिए set of functions you are providing already by selecting your neural network. For example, if you chose single neuron, ठीक है, आपने you provided it, there are let's say 3 inputs, yeah, coming into a single neuron, yeah, and what it does is it weighs them. So let's say W1 x1 plus W2 x2 plus W3 x3. Then you say I will apply an activation, let's say step function, yeah. So you have now done sigma applied to W1 x1 plus so on, yeah. Now what are the values possible here? What are the different things possible? All you can play with in this structure is what? W1, W2, W3. So the set of functions in H is what? All the possible values of W1, W2 and W3. It cannot be that you cannot expect, since you did not put a term which says let's say W5 x1 times x2, वो आपने structure में नहीं डाला ना आपने. So you cannot expect that is also a candidate, right? So your candidate is basically जो भी आपका function है, model है mathematically, उसमें जो parameters adjust होने हैं, उन सब की सारी possible values उसमें अगर आप डालते जाएं, जितने functions निकलते आएंगे, वो सारे एक एक candidate होंगे, right? और फिर उनमें से कौन सा best है, तो, right? So it's decided by that. Right. So what is a feature and what is a label? So idea है थोड़ा सा किसी, right? But we are going from the very basic. So even if you don't know, it's fine. Feature क्या होता है वैसे अगर किसी को पता है machine learning में? Yeah. Some characteristic of the data. Very good. और label क्या होता है? उस characteristic का नाम होता है या? Okay. Anything else? Like in machine learning में? Exact value of those features. और कोई? Okay, so let's see what it is. Some characteristic of the input data. It could be the whole data itself. Okay? You may say this is what I recorded. This is my features. Yeah. So we sometimes use them interchangeably. Sometimes you will take out some characteristics of the data, and we will call those features. But labels are basically another name for the output, okay, that these features have to give. Yeah. For example, here, let's say you have to predict the price of houses in some region in America. So there are features. You input these features. You give it 4 features. What are those? Size of the house, how many beds it has, how many baths it has, which zip code इस region में है, ये zone कौन सी है, and based on that maybe 1.29 million dollars का है, ये इतने का sale होता है, ये these are the values that you want to predict, that if I give you now 3 or 4 of these for another house, what should be the predicted value, yeah, or what should be a fair value based on the current market situation. Yeah. So in this one, these are features, okay, these are the input values. Labels are the output values corresponding to the features. Okay. So label का अब से ये मतलब नहीं है कि उस पे label है कि ये अच्छी गाड़ी है, good or bad. सिर्फ it's not necessarily categorical or descriptive label. Numbers हैं ये, numbers भी हो सकते हैं, as जैसे इस case में. Yeah. So label is just another name for output data. Training data. What's training data? जो लोग already थोड़ा बहुत काम कर रहे हैं machine learning, on which the model is trained. So it's those features and labels which we are sure of already. Yeah, जो हमारे पास पहले ही होता है. Function approximation में या curve fitting में training data क्या होता है? वो points जहाँ पे आपको function की value मालूम है. That is training data, right? So in a way that is what's happening here also. So Training data are those mappings that you know for sure, or at least you claim we know those. Yeah, they may or may not be available. We will see this also. Supervised learning versus unsupervised learning. Okay, we will see that. But if they are available, very good. They will help us train our machine learner, whatever the system that is. So training data is pair of known features and labels. जो आपको पता है पहले से, उसी पे ट्रेन करेंगे, right? जो पता ही नहीं उस पे आप नहीं कर सकते. Right. What is a model in mathematical sense? Right. So mathematics में तो modeling जो है वो it's a mathematical representation, a structure and corresponding interpretation that summarizes or partially summarizes a set of data for description and prediction. Nicely summarized. Yeah. क्या है ये? It either summarizes or partially summarizes some set of data. Summarize समझा दिए कि minimal mathematical notation में उसको present कर देता हूँ. Yeah. Now you could represent data with a model with जो हम बनाते हैं y equals mx plus c is a model of a line. Yes. So parabola के अपना एक model है. Yeah. So we have models, various kinds of models in math. There are mathematical models. This guy is also a mathematical model. इसकी equation देखी थी हमने थोड़ी बहुत, वो gx वाली for one layer. Yes. वो जो equation बनती है वो model है. Right? Maybe this doesn't look mathematical here, but of course we always translate it into mathematics. F is summation, alpha, sigma, all that. Yeah. So this is a mathematical model, and again notice for what is their purpose often? For description or prediction. To describe the system better or to predict it, and once we predict things we can also maneuver things. So that is a model. Now a model could take many shapes. This is data, let's say, yeah, 0.998. ये कुछ समझ आ रही है क्या डेटा है ये? Guess कर सकते हैं? Okay, good guess. Try start अच्छा है, आगे चला. Next. आप शुक्र करें इसके रटे नहीं लगाने पड़ते. ये अब वो उसमें कैलकुलेटर में होता है ये सब में, पहले टेबल देने पड़ते. These are the values of this guy. Cosine x, that's a model. Yes, so trigonometric function is a model. It models a very specific kind of data. इस तरह जो sinusoidally vary करता है. Yeah, but that is not the only model. Yeah, you could, yeah, sine भी हो सकता है with the phase change, but you could say I want to model it like this. That's also a model. ये कौन सा model है? Taylor series इसकी approximation या expansion है ये. Yeah, but you could say no, I don't want to model it like this. I want to model it like this. ये भी cos x है और वही data है. Right? What is this model? हाँ, एक्सपोनेंशियल फॉर्म में कौन देता है? कौन सा ट्रांसफॉर्म है? ऑयलर तो एक आइडेंटिटी है ना. ये फोरियर रिप्रेजेंटेशन है. फोरियर ट्रांसफॉर्म ये कहता है. पोलिनोमियल और टेलर कहते हैं कि विल राइट इट इज एक्स स्क्वायर एक्स क्यूब. या रिमेंबर डिस्क्रिप्शन. या नोटिस क्या डिस्क्रिप्शन नजर आ रही है यहाँ से कोसाइन की. फ्रॉम हियर कैन यू टेल मी इज कोसाइन एन इवन फंक्शन और एन ऑड फंक्शन? इवन फंक्शन, राइट. जिसकी नेगेटिव और पॉजिटिव वैल्यू x की डालें तो सेम जवाब आता है. वहाँ से आपको नजर आ रही है बिकॉज ऑल द इवन पावर्स आर देयर, नो ऑड पावर इज देयर. सो डिस्क्रिप्शन हो रही है, प्रिडिक्शन हो सकती है, इंटरपोलेशन हो सकती है. Fourier says we'll do it like this, but you're not limited to that either. You could say no, because there is a universal approximator also, another guy. This guy, I would like to write cosine x as a linear combination weighted and gated, or let's say activated. Yeah, I would like to write it like this. Again, by the way, कल मैंने बताया था limitations में overkill का बताया था, जहाँ ज़रूरत नहीं है वहाँ ना पंगा ले कोसाइन को मॉडल करने कर सकते हैं आप, ठीक है, but it's not a very smart thing to do. कोई ख़ास ज़रूरत नहीं है आपको, right? But it will still approximate your cosine. Okay, so all of these are models. Yeah, in this course we'll mostly be looking at these kinds of models. Yeah, previously you have been looking at this kind of models. Why? As I said, these are more amenable, easier to devise a learning strategy for, which is not too computationally hard. Yeah, so ये हमारा interest उसमें है. So model ये हो गया, summarizes data for prediction and say algorithm क्या होता है? Set of rules or procedure that leads to some goal or something. It can also be something that describes how to perform a task from that perspective. So then remember this one, we found the values of A and B iteratively, एक हमने किया था. So that I had written these rules, these steps there, we followed them and we found the values of A and B. This was a algorithm, right? So algorithm we know now, it's a set of rules. And types of algorithm, there are several types. It's good to have some idea about them, because we would want to maybe change the kind of algorithms that are being used in machine learning. Yeah, so there are many kinds, I won't cover all of them, but I'll give you a quick idea about some of them. आप लोग कोई कोर्स लेते हैं algorithm पे? ऑप्टिमाइजेशन आप बैचलर्स में कोई लिया हुआ नहीं? ऑपरेशन रिसर्च अगर लेते हैं तो इलेक्टिव्स में होते होंगे कुछ कोर्सेज, राइट? सो एनीवे आई विल जस्ट कवर देम वेरी क्विकली. एक एल्गोरिथम होता है ब्रूट फोर्स. या ब्रूट फोर्स क्या होती है इंग्लिश में? अन्यवाज, बेसिकली अन्यवाज होला, ठीक है. ब्रूट, जंगलियों की तरह फोर्स बस लगा देना. या brute force algorithms, what they do is they systematically check all possible candidates against a given criteria. इसको हम exhaustive search भी कहते हैं, ठीक है. वो होते हैं ब्रीफ केस होते हैं जिसमें 3 कोड होते हैं, 3 होते हैं. लेट्स से आप भूल गया और कोई आपके पास तरीका नहीं है. ब्रूट फोर्स क्या होगा? 0 0 0 0 0 1, right? Just go through all of them. Yeah, but you are sure to find it. ब्रूट फोर्स का ये कमाल है. yes, you sure to find the optimal point या the key, but problem क्या है उसमें? टाइम बोल लेता है. but it can, फिर इसका एक और इस्तेमाल फिर हम क्या करते हैं, लेकिन एज ए रेफरेंस तो यूज़ कर सकते हैं ना, कि जो ब्रूट फोर्स से ये वाली मिनिमल वैल्यू निकली है, this is the actual minimal because this was brute force, we checked everything. right? So it can be a benchmark for your algorithms, reference ban jata na, you can compare your results with it. So here for example, you know, if you want to find the path with the maximum sum, so brute force would say try this, then this path, then this path, and just choose the one which gives you the maximum sum, right? Brute force would say this, which is fine in a small system, but of course greedy algorithm, अब पहले बंदे greedy होते थे, algorithm भी greedy हो जाते हैं. या greedy algorithm क्या करता है? Systematically makes the locally optimal choice at each step. या तो greedy sense में है ये कि ये इसके बेचारे के ज़हन में doesn't have the bigger picture in mind कि क्या हो, बस अभी छोटा सा मुनाफा हो जाए या अभी फ़ायदा हो जाए, इस पॉइंट पे मैं क्या कर सकता हूँ. या so it makes locally optimal decision without bothering about global optimality. So for example, if a greedy algorithm was to do that same thing, you know what it would do? It will start somewhere, yes, and it will at this point इट विल सी ग्रीडी है, वो अब आगे देख ही नहीं सकता बेचारा ज़्यादा दूर तक कि देर पा फ़ायदा क्या है. इट विल से इज़ 12 बिगर देन 3. यस, सो द ग्रीडी चॉइस इज़ कि आगे नहीं देखना हमने एक कदम आगे नहीं देखना, बस सिर्फ जो पहला स्टेप है वही देखना है. राइट, व्हाट इज़ दैट स्टेप सेइंग? चूज दी, इस वक्त जो मैक्सिमम मिल रहा है ले लो, बस ग्रीडी हो जा. राइट, दैट्स अ ग्रीडी एल्गोरिथम. प्रॉब्लम क्या हुआ इसमें? You could miss, yes, you could miss that. Then why would we use greedy algorithms? ये थोड़ा सा आपका होमवर्क भी है, सोच के आए इस पे या ये इसका क्या फ़ायदा क्या हो सकता है? ईजी होते हैं, सिंपल है ना ये रूल, राइट? एंड यू हैव ऑलरेडी हर्ड और सीन one greedy algorithm upon which a lot of machine learning is built. The gradient descent is a greedy algorithm. ये हर every point it just looks at the local slope, right? In a way, in that sense, it's a greedy algorithm. फिर क्यों करते हैं हम ये? Last time I showed you. What's the alternative? One alternative is brute force. Not a good, no time नहीं है, right? The other alternative is to do it analytically. That is, take the whole global picture in view. That gets too complicated also analytically. So often this is the best shot we have. It is heavily used in neural networks, and तो समझ आ गई greedy algorithm क्या होते हैं? We choose the local best for the next step. Yeah, they don't care about what's coming up ahead. Greedy, yeah, they can work. अभी तो हम because they are gradient descent will, of course, if there is discontinuity, the gradient would disappear, right? So or be infinite, so you will have to उसके हमारे पास approximations फिर होती हैं, right? So we'll see that. Divide and conquer algorithm. Recursively break down a problem into two or more sub-problems of the same or related type, right? So what they do is they break the problem into smaller problems until it is easy enough to solve. So for example, if you have to sort these numbers 32, 27, 43, 10, yeah, so you have to sort them. What you can do is you can split it, yes, break down the problem into smaller set, yes, and then if you can break it even further, fine. अगर ये list ज़्यादा बड़ी होती तो we'll break it many times, and then until it becomes simply very trivial to check is 27 bigger than 2038 or not. Swap them, and then put them all back, and you have your answer, right? So divide and conquer algorithms divide the problem into several sub-problems and solve those problems, okay? Then there is dynamic programming, okay? What is that? It also does what divide and conquer does, but it does it even more smartly. It divides the problem into overlapping sub-problems to save computation. Now remember this, it may not always be possible to find overlapping sub-problems. If they don't exist in your task, then you cannot use this. But if they do exist and you're not using this overlapping structure to save computation, then you're wasting a lot of computational effort. Okay, so always try to find a structure in the problem which can help you. For example, so basically it's a divide and conquer but with some additional structure. Let's say this one. You want to get from A to B, A to J, and this is the distance. Yes, find the route that is shortest. ठीक है, यहाँ अब algorithms काम आना शुरू हो जाते हैं. Brute force would say what? सारे try कर लो और आपको minimum मिल जाएगा. राइट लेकिन उस वक्त तक आप थक चुके होंगे, पेट्रोल ख़त्म हो जाएगा ठीक है. सो कॉस्ट बहुत ज़्यादा है उसका, बट इट्स श्योर टू गिव यू दी एब्सोल्यूट मिनिमम, बिल्कुल मिल जाएगा. राइट ओके. ग्रीडी क्या कहेगा? Greedy will say, okay, start. If you start with A, check the shortest at A. 2 है या 3 है? It's 2. Then at B, which is the shortest, check that. That's what greedy would do. Okay. But what would dynamic programming do? Now, dynamic programming will try to see if we can divide this problem into overlapping sub-problems. So, I'll show you here what we mean by overlapping sub-problems. Note that from the perspective of B, C, D, if you are standing at B, yeah, what will you check? 7 plus 1 plus 3, 7 plus 4 plus 4, yeah, and C will also check those again. Notice this triangle, this one here. Between among these paths, if you want to get from E to J, should you take E at J or E I J? कौन सा लेना चाहिए? मैं बता देता हूँ. 1 3 है ये और this is 4 4. E at J लेना चाहिए आपको, right? Now, if you are standing at B, C or D, does this change? किसी पे भी खड़े हो आप, उनमें से तो आपको वही लेना चाहिए, right? So, you don't actually need to check this thing every time with B, C and D. Similarly, this other triangle, this diamond shape here, from F to J, F at J or F I J, yeah? So, it's basically F I J. This is just 7, yeah? So, from standing here, you don't need to check every time both of these paths, right? Each of these can be checked once. So, you could replace the whole thing with just the minimum path, right, which is 1 plus 3. We say from B, from C, from D, wherever you are coming from, if you get to E, don't take this path IJ, take the EH J path, which will cost you, or which is 4 kilometers or whatever this is, yeah. So, but then it doesn't stop here. I could repeat this thing from perspective of A also. From the perspective of A, what's the shortest route from B to J? What's the shortest route from C to J? What's the shortest route from D to J? Yeah, I don't have to check the whole thing every time, yeah. So, what I can do is basically divide this thing. Mathematically, I hope you will agree that the minimum of A to J is actually the minimum of 2, meaning A to B, plus minimum of B to J, however you get there, that should be the minimum. Or this is one candidate from perspective of A. Or you go to C, which will cost you 4, plus the minimum of C to J, yes, plus or this one. But now the minimum of B to J is again similar, and that is again similar. We come to a point where you just have to calculate these minimums one time, that's it, yeah. सारे H J I J आपको पता है क्या values हैं, 3 4, right? Then find minimum of EJ, minimum of FJ, minimum of GJ using these two values. एक एक दफ़ा calculate कर लें, ठीक है? Use those to calculate these and use those to calculate these. Now this is very nice between somewhere between brute force and greedy. Yeah. So you are finding the actual minimum without having to do all the calculations. Yeah. So इसको दोबारा भी आप देखना. Overall, you can see the overlapping problems. नज़र आ रही हैं overlapping parts. Yeah. So this is the idea of dynamic programming to optimally things. डायनामिक प्रोग्रामिंग की ट्रांसफ़र लर्निंग का मतलब वो एक ब्रॉडर चीज़ है. डायनामिक प्रोग्रामिंग I don't think transfer learning is directly related to that. Okay. Dynamic programming, yes, a smaller problem solves itself and gives its solution to the bigger problem. The bigger problem then solves itself and gives the solution to the so it's nested. Yeah. Transfer learning is what you have. You trained a machine learning algorithm on cars. ठीक है, उसने लर्न कर लिया कि ये कार है या बंदा है. Now you want that same learner to, without having to spend so much training time, very quickly learn that if this is a bus or a person. This is transfer learning. How you get there? You could use some parts of dynamic learning, but I don't think dynamic learning alone can give you transfer learning. वो बड़ा field है. It's very new field. Right. So again, just to summarize, there are many names for input, output, and what happens in the machine. Input terms are, we sometimes call them input, features, predictors, attributes, independent variables. जो maths में ज़्यादा कहते हैं. Yeah. Output, classes, responses, targets, dependent variables. Yeah. And what happens in the machine? Model, technique, algorithms. Yeah. So what we have looked at is a little bit of each of these. Now, since we hear these terms, again, what we are doing is going through the vocabulary. Yeah, so we started with learning. सिर्फ machine मैंने define नहीं की बात, लेकिन आपको machine तो पता ही आएगा. Yeah, so we defined learning. Then we went on to define model, data, input, output. Then we linked them to features, algorithm. Yeah, greedy algorithm, brute force algorithm. और ये आपको वो when you read papers, you will see that they will say, well, we compared our results to brute force. तो अब आपको at least वो परेशानी होगी कि क्या इन्होंने उसके ऊपर जोर लगाना शुरू कर दिया. Brute force. Yes, you will know they are talking about exhaustive search, everything checked. So here the relationship between AI, ML and deep learning. तीन टर्म्स हैं, बहुत से लोग मिक्स यूज़ करते हैं. फर्स्ट ऑफ ऑल, एज दिस काइंड ऑफ अ वेन डायग्राम ऑल्सो. या वेन डायग्राम याद है ग्रुप्स वगैरह में? ओके, सो machine learning is a part of AI. I mentioned that before. It is one part of AI. AI is what? AI is when you see a system or a machine that is behaving or displaying intelligence. वो AI, ये बड़ा फील्ड है. ठीक है, हाउ इज इट एबल टू डिस्प्ले दैट इंटेलिजेंस, इसके ब्रेन में क्या चल रहा है, दैट इज मशीन लर्निंग. राइट, एंड विद इन मशीन लर्निंग देयर इज दिस न्यू the artificial neural networks. Basically we will see that, but within that the artificial, because machine learning is not just neural networks, there are other techniques also. Yeah, so within machine learning, the neural networks, especially neural networks with many layers, that is deep learning, जिसका आजकल काफ़ी शोर मचा हुआ है. Right, so just to give you an idea, when I say that AI is not just machine learning is one part, then you should wonder what else is here. Right, वो हमने नहीं करना इस कोर्स में. ठीक है, उनके लिए अलग कोर्सेज कंप्यूटर में भी ऑफर होते हैं, हमारे तरफ भी हो सकते हैं. बट व्हाट एल्स इज देयर, जस्ट टू नो, इट्स अ गुड आइडिया टू नो. सो आर्टिफिशियल इंटेलिजेंस ब्रॉडली covers computer vision, robotics. There is our guy. Machine learning, automated reasoning, knowledge representation, which is more of a psychology thing, and natural language processing. थोड़ा बहुत overlap हो सकता है कि natural language will use some of machine learning, yes, but in itself it's also a field. Okay, coming from linguistics, trying to understand the linguistic behaviors. So हम यहाँ पे हैं, machine learning. Right. अब आखिरी ये रह जाता है जो आजकल बहुत ही ज़्यादा आसमान पे चढ़ा हुआ है, generative AI. Yeah, and the generative AI is basically, its aim is to produce new material that will fit in different classes. देखिए अभी तक machine learning या deep learning क्या करती आ रही थी, जो most of it is doing what? It is predicting, it is classifying, yeah. But generative AI एक step आगे जाती है. वो क्या कहती है कि मैंने ये गाड़ी बनाई है और आई एम श्योर कि ये गाड़ी की तस्वीर है. ठीक है, यानी क्लासीफायर ये करता है जो इससे पहले है लर्निंग, दैट विल टेल यू कि दिस इज, आई एम 99% श्योर दैट दिस इज अ कार, आई एम 99% श्योर दैट दिस इज अ गुड, और दिस इज या अ गुड पोएम फॉर एग्जांपल जो मैंने दिखाई थी. बट जनरेटिव एआई विल से I can write a poem and also check if it is a good poem. So now it is able to learn what is a good poem and not just identify them but also create new ones. अब उसके लिए कुछ नई strategies आई हैं ना, जिससे ये चैट जीपीटी वगैरह पॉसिबल हुआ है. उसको हम कहते हैं ट्रांसफॉर्मर. It's the latest version of neural networks, the transformer. Yeah. So but to give you an idea, ये रही artificial intelligence, there is machine learning inside it, deep learning is the neural network parts. तो बाकी machine learning फिर क्या होती है, किसी को idea है? है ना, it's just one part of machine learning. What else is there? There is statistical inference. Okay, we will see that also, but for now let's go. Yeah, so it is here anyway. This is the map of machine learning. Yeah, और ये आपको इसकी काफ़ी क्लैरिटी याद नहीं करना, लेकिन क्लियर होना चाहिए आपको. There is no universal map. थोड़ा बहुत variations हैं, people have their views, but broadly speaking, machine learning has three main branches. Okay, there is classical learning, there is reinforcement learning, there is ensemble learning, and this is, sometimes we write it deep learning, but basically neural network based learning. Okay, now in this course we will cover classical and parts of this guy. Reinforcement and ensemble are not covered here. Okay, क्योंकि हर एक कोर्स में वो ज़्यादा हो जाता है. Yeah, so let us see quickly a broad idea of classical ML. If you have enough data and the features are defined clearly, then just go for classical ML. Yeah. If you have complicated data and unclear features, just written jokingly, belief in a miracle, try neural network. Yeah. Reinforcement learning is actually the next level of everything in the sense that in reinforcement learning you don't train the device. So there is a robot. It has been told that if you bump into something, you will get -1 point, right? That's it. और फिर उसको इस कमरे में छोड़ देते. ठीक है, अब वो ढूंढ रहा है कि मैंने किस तरह बम्प नहीं करना. जब भी बम्प करेगा उसको एक पेनल्टी मिलेगी, तो उसको याद रखेगा कि इस पॉइंट पे मैं नहीं जाना दोबारा. दैट्स रीइंफोर्समेंट लर्निंग, लर्निंग फ्रॉम द एनवायरनमेंट. दैट इज़ हाउ मोस्ट ह्यूमंस लर्न, राइट. सो ये मतलब मोस्ट एडवांस लेवल है रोबोटिक्स वगैरह का. बट ऑफ कोर्स वी विल स्टे हियर क्लासिकल ML एंड something happened. Let us see. लॉक हो गया. स्क्रीन ऑफ हो जाती है तो ऑन कैसे होती है? ये वाला या पावर की दबानी पड़ी? ओह नाइस. चाहिए सॉर्ट ऑफ स्क्रीन लॉक है उसका. Right. So in the first phase, we will look at some of these. So I'll just maybe cover some of these. The next, most of these we'll cover next time. This part here is the classical machine learning, also known as statistical inference. Okay, ये machine learning का part है. It has been around for a long while. I can tell you this, जो आजकल नई revolution है, that's not because of this one. Okay, but इसको सीखे बगैर आगे जाना भी अच्छा नहीं है. Yeah, so the modern revolution is because of those guys up there. उसी के अंदर generative AI वगैरह, but they are built on a lot of these concepts, and these are also currently heavily in use. As I said, not everything requires machine learning, and within machine learning, not everything requires neural networks. You can solve a lot of problems with statistical machine learning or classical machine learning. Okay, so in there we have some basic ideas. Regression. So now a regression ka. Yeah. So regression is what I just like to call it kind of another name for curve fitting. Yeah. So when you're doing regression, you are trying to fit a curve. Let's say I have the number of hours a student studied for the exam, and the marks the student got in the exam. So if I plot these, yes, and I get this kind of plot, and I want to fit a curve in there, yeah, to model it. Yeah, that's a regression. You're fitting a curve in there. Yeah, ये पॉइंट सारे एक लाइन पे फॉल तो नहीं करते अगर लीनियर भी है तो. लीनियर रिलेशन भी है लेकिन दे डोंट फॉल ऑन अ लाइन. क्यों? रैंडमनेस होती है. रियल थिंग्स आर नॉट एग्जैक्टली द सेम. ऐसे बच्चे होंगे जो ज़्यादा पढ़ के थोड़े से कम नंबर आ जाएंगे उनके, राइट. तो द थिंग्स डोंट फिट योर y इक्वल्स mx प्लस c. या थोड़ा ऊपर नीचे होते हैं. So that's where curve fitting can come in statistically. So this is linear regression. Again, we will do them mathematically later. या अभी सिर्फ आपको उसकी sense होनी चाहिए. When you hear about regression, what are we talking about? Curve fitting. Yeah, you have some data, you want to fit a curve into it. You are not limited to linear curve fitting. You can fit non-linear curves, and that we will call non-linear regression. Why do we do it? Prediction, extrapolation, interpolation, all that. Yeah. So in regression, basically remember this guy, there were input terms. Where is the input in this case? Features, number of hours you studied. Yes. What are the labels or output? The score, the marks you got. Yeah. And that is now acting as the training data to help me find this curve. Yeah. So there is training available. So we will call it supervised learning. This curve was obtained based on available data. X और Y की mapping मौजूद थी हमारे पास. Yes. So whenever you have those available and you use them, you are doing supervised learning. Yeah. Then you are not limited to 2 dimensions, single variable also. You can have multiple variables. So maybe you have data about how many hours the student studied, how many marks they got in the prep exam or a major quiz, and then how many marks they got in the final. Yeah. In that case, these two might be your input features, and these are your label. And then I want to say, okay, if a student studies 5 hours and gets 5 marks in the prep, कितने marks आने का chance है, pass हो जाएगा कि नहीं, right? So you are not limited to one independent variable. Independent variables can be n. Yeah. Then we call it multiple linear or multiple non-linear regression. Yeah. Then we are also not limited to fitting deterministic curves or just curves. We can also try to find maybe probability curves. We sometimes fit probability curves to categorical data. What does that mean? Suppose I know how many hours different students studied, and then I know if they passed or failed. Yeah, this is categorical now. पास को मैं 1 कह रहा हूँ, उसको 0. Compared to this, पहले क्या था, actual marks थे उनके, ordinal था वो. This is categorical. Yeah. So now I want to find a curve, a probability that जो 3.5 घंटे पढ़ता है उसकी क्या probability है पास होने की, या और जो 5 घंटे पढ़ता है उसकी क्या probability है पास होने की. So sometimes the curve we try to fit is a probabilistic curve. या और इसको क्या कहते हैं, regression की कौन सा नाम है इसका, मशहूर है आजकल, logistic regression. Yeah. So this is we will come to this also later, but just I wanted to show you that curve fitting doesn't mean कि आप एक सिर्फ ऐसे curve fit करें. The curve could be a probability curve, okay, fitted to the data. So that's what you have fit in here. Classification, बस ये बता के थोड़ा सा we'll stop that here. Regression क्या था, fitting curves. Yes, supervised learning है because to fit curve you need the data. Yeah. Classification is also about curves, but not the curves fitting curves. They are delimiting curves. Boundaries तलाश करनी है, ठीक है, क्यों क्रॉस हो जाए तो चौका हो रहा है, ठीक है. You have to find the boundary. Delimiting क्या होता है, यानी जो limit यानी उसकी boundary basically. Yeah. So if you are finding boundaries, then you are doing classification. What does that mean? So suppose I give you some training data, labeled data is provided to you, yes, and you have to find the boundary between them. Yeah. So I've told you these circle means these belong to one class and this means they belong to another class, and now you have to find a curve that is, and once you are trained you will use it to identify. Then I'll give you a new data point and I'll ask you, does it belong to class A or class B? Yeah. So that is, again, it is supervised. Why is it supervised? Because I gave you the labels. Yeah, I told you this is data A, this is data B. All you had to do was find the line. Yeah. So you could convert, याद है अभी हमने वो जो line बनाई थी, that was regression. Yeah. But what if I asked you to find, I gave you, okay, these are the two data points x1 and x2. Students studied 3 hours, prep exam में उसके 2 आए थे, finally वो fail हो गया. Yeah. So इधर pass हो गया, इधर fail हो गया. Now based on this is your training data. Based on this, give me a divider कि कौन सा area है, कौन सा mixture है इन दोनों का which leads to failure, and which mixture of these leads to success. Yeah. So this curve was regression and this curve now is classification. Yeah. So again, over here you could use the, if you have this logistic regression, the probability curve, that is regression. But if you apply a threshold on it, above this I will say the student is going to pass, below this I am going to say the student is going to fail. तो ये classification बन जाती है. Yeah. So in a way regression can help you create classification, but not always, it's not a must. So we are not limited to linear boundaries. That means it's not, let's say, necessary that the boundaries we find are lines. We could find non-linear boundaries. So this is called non-linear classification. Yeah. Then there is the, we are not limited to 2 dimensions. You could have data that is in multiple dimensions, like here. Now you are not finding a line, you are finding a plane or a hyperplane between the classes. Yeah. In fact, sometimes we trick the system. A non-linearly separable system in lower space might actually be linearly separable in a higher space. So we will see that also. But in any case, we are not limited to 2 dimensions. We are also not limited to just 2 classes. Yeah. So if you just limit yourself to 2 classes, that's called binary. Otherwise, it's called multi-class classification. So now you are looking for boundaries between 3 classes. Again, it is still supervised because we tell you what the classes, where the members of the classes are that we know. Yeah. It could be here 3 classes, you have to classify between them. So we could also identify multiple labels within one input. So it could be that you want to find, this is called multi-label classification. I give you one big image, and inside it you have to tell me, is there a truck, a boat, a dog, plane. You have to label them, okay, which different classes are inside that image. Yeah, this is what we call multi-label classification. Just last thing about classification here is, just keep in mind, you might look at it and say, what's so hard about it? Yeah, I can draw a line. आप मुझे दे दे. Yeah, but reality is not like this. Usually reality is like this. Outliers है, mix हुआ हुआ है वो बहुत कुछ. You have to find which curve incurs the least amount of loss. Yeah, so it's not, yeah, देख के तो यही लगता है कि हाँ बस बीच में एक लाइन लगा देंगे, क्या करना है. Yeah, but reality is not that way. So next time we will look at clustering. So we looked at regression and classification. Yeah, next time we'll again, this is, all of this is being done on a higher level. तो अब से अब आप जब regression सुने तो क्या ज़हन में आना चाहिए? Curve fitting. Classification सुने तो क्या आना चाहिए? Delimiting. Yeah, finding a curve that gives you the boundary between them. Yeah, okay, thank you. मैं ये stop करूँगा. Questions हैं तो you can ask. अगर अभी class है तो you can also go for that.